Today's class we will discuss about expectation. The expectation, which is also known as mean, average or expected value. The indication of expectation is E. Random variable is written within a square bracket. This is also notated as mx. We'll discuss the formulas to find out the expectations. The mean of for the discrete random variable, the mean is given by, that is average is given by mx is equal to expectation of x. This is also written as x bar is equal to summation of I is equal to 1 to n xi into p of xi. Mean of the continuous random variable is integration from minus infinity to infinity x into fx of x dx, where what is this fx of x is? This is the PDF, that is probability density function. The same, suppose the mean of any function g of x which is given as mean of, that is expectation of g of x is equal to integration from minus infinity to infinity g of x into f of x dx. In the same formula, instead of x they have written it as a g of x. If we compare these two formulas, here it is x, here it is g of x. For the same formula, in the place of g of x, if we substitute x power n, the formula is reduced as x power n integration from minus infinity to infinity x power n fx of x dx. Suppose the x value, n value is 2, that is integration from minus infinity to infinity x square fx of x dx. This is known as mean square value. Next we'll discuss about variance. Variance is indicated by sigma x square, that is equal to expectation, that is average of the random value minus mean of it. That value square expectation is the variance. For the continuous signal, it is given my integration from minus infinity to infinity x minus mx square into fx. This is a formula of expectation function. In the place of g of x, we have substitute as x minus mx square. Here we'll go back to these two terms. We'll write these two. So we'll expand this using the a minus b whole square formula. That is x square minus 2x mx plus mx square. We'll take expectation of each term. Expectation of random variable square, that is expectation of x square minus expectation of 2 into random variable x into its mean mx plus 2 into mx square. Further simplifying this, expectation of x is a random variable, so we'll keep as it is expectation of x square. The next term is expectation of 2 into x into mx. Here 2 and mx, that is average value of x and 2, both are constant. We can take it outside, that is 2 mx into expectation of x is mx. Here expectation of x is mx, which is getting here, plus expectation of mx square is mx square, that is a constant, so that constant itself. So further we'll reduce, this will become minus 2 mx square, this is plus mx square. The further reducing this, we'll get sigma x square is equal to expectation of x square minus mx square. That is, variance can be found out as mean square value minus square of the mean value. This is square of the mean value. This is mean square value. Next standard deviation is square root of the variance, that is square root of this value. We'll solve the first numericals in this. We'll solve this. Consider the transformation of y is equal to ax. Obtain the mean variance in terms of mx and sigma x square of x. So first we'll write what is the equation for mean. Mean mx, which is also known as expectation of x, which is equal to here we wanted to find out expectation of one function y is given. So that is my is equal to expectation of y, which is given as expectation of ax plus b. So we will take expectation for the each term, expectation of ax plus expectation of b. Here in these two terms, a is a constant, x is a random variable. Expectation of constant is the constant itself into expectation of x. Here b is also a constant. Expectation, that is the average value of a constant, is constant itself. So a into expectation of x, we can notate it as mx plus b. This is a formula. This is a solution. So what is the second part they have told us to calculate? Sigma y square. To find a sigma y square, we want expectation of y minus my whole square. In the place of y, we'll substitute add ax plus b. Expectation of ax plus b minus what is my is just now we have calculated a into mx plus b. We'll solve this. E is equal to ax plus b minus amx minus b whole square. So this will be plus me minus b cancels. Expectation of ax minus amx. A common in both. We'll take it outside. A common from this, and square of a we can take expectation of a common, x minus mx whole square. We can take a square for each individual term. This will be expectation of a square into x minus mx whole square. Now this is the expectation of a square into this term. A square is a constant. The square of the average value of a square is a square itself. Expectation of x into mx square. By the definition of variance, this is notated as the variance of x, that is sigma x square. So sigma y square is equal to a square into sigma x square. This is a solution.